Hi, hello everyone. Welcome to SK Academy of Mathematics. Today we are going to learn how to solve the problem on Taylor series method. Considering the given differential equation, we are going to find the value of y of 1.1 and y of 1.2 by the given set of initial values y of 1 equal to 2. How to represent the solution and how to define the solution, I am going to explain step by step. First, let us represent the given solution. Given, what is the given? That is dy by dx, which is equal to log x into y, and where y of 1 equal to 2. This y of 1 equal to 2 can be represented as y of x naught equal to y naught, where x naught represent also x naught represent 1 and y naught represent 2, and got the point. Similarly, y dash can be defined as dy by dx and y double dash can be represented as d square y by dx square. Similarly, it goes on. Now dy by dx can be represented as y dash, which is equal to log of x comma y. Now this is the given condition. Now considering this given condition, we are going to represent Taylor series method. That is by using Taylor's series expansion. We have the Taylor series expansion is given by y of x, or else you can represent the function is also as y of x also. Then defining the condition, whatever we are going to represent in the formula, where before we represent the function in with respect to y of x naught, plus next we have x minus x naught into y dash of x naught plus x minus x naught divided by x naught whole square divided by 2 factorial into y double dash of x naught, plus since they have not asked how many degree, always remember they have asked for 7 marks, you are supposed to represent 4. If they ask for 6 marks, you are supposed to represent Taylor series for up to 3rd degree term. Now they have asked for 7 marks, let us solve for 7 marks. Plus x minus x naught whole cube divided by 3 factorial y triple dash of x naught plus x minus x naught whole to the power of 4 by 4 factorial y 4th degree of x naught goes up to etc. Got the point? Yes. Now we are going to represent the terms step by step. First we are going to represent y of x naught. See, we have the value. Let us go with the term by term. See, okay, we are supposed to find the value of y of x naught. We have the value of y of x naught, that is 2. Got the point? Next, I am supposed to simplify. I have x. X is the value which I am supposed to find of the given. Find the value of y of 1.1. In that place, we are going to replace x. Got the point? But we have x naught. X naught is 1. We have represent x naught. We are supposed to find y dash of x naught. What is this y dash of x naught? That is y dash of x. Consider dy by dx, which is equal to log xy, x into y. Now we are supposed to represent dy by dx as y dash, which is equal to log a into b can be represented as log a plus log b, where log x plus log y. Got the point? Now y dash, which is equal to, now I need to find the value of y dash. So in place of y dash, I need to substitute the value of x and y. Now to simplify x and y, what I am going to consider? I am going to consider this as x and this as y. Got the point? Now the place of x. Now while simplifying in the calculator, log will be replaced with respect to ln 1 plus ln 2. Y dash of x naught. Since it is represented as x naught, y dash of x naught, which is equal to ln 1. What is ln 1? Ln 1 plus ln 2. Ln 2. You get 0.6931. This is the value of y dash of x naught. This is the value of y dash of x naught. See, we have found y dash of x naught. Next, we are supposed to find y double dash of x naught. How to find y double dash of x naught? Now let us represent here itself. Okay. Consider. Okay, I am going to erase this little bit. I am going to represent here. Okay. That is x minus x naught whole cube divided by 3 factorial into y triple dash of x naught. Since I don't have space, I am going to represent. Okay. Now let us substitute. See, we have found y dash. Next is y double dash. So what I am going to consider? I am going to consider what I am going to represent this condition, that is y dash, which is equal to log x plus log y. Okay, I need to differentiate with respect to x. Differentiate partially with respect to x. After differentiating, y dash becomes y double dash. Why? Since y dash is differentiated with respect to x, if I again differentiate, it will becomes y double dash, which is equal to differentiation of log x, that is 1 by x, plus differentiation of log y partially. So what happens? 1 by y. Differentiation of log y is 1 by y into dy by dx. Now y double dash, which is equal to 1 by x into dy by dx, I can represent it as y dash. Y dash by y. Got the point? This is the next derivative, that is second derivative. Got the point? 1 by x plus y dash by y. Done. Now let us simplify the values. Y double dash of x naught, which is equal to 1 by x. What is the value of x? I have represented. This is the important part. This is the value of x. The value of x is 1 plus y dash. What is our y dash? 0.6931 whole divided by y. What is the value of y? That is 2. Y double dash of x naught. Okay, either you can replace y x naught as 1 also. Let us simplify the next procedure. What the point? Yes. Now just simplify. 1 by 1 is 1 plus, again numerator denominator, 0.6931 divided by 2 plus equals, you get 1.3465. This is the value of y double dash. Got the point? Yes. See, we have completed y double dash. Next step is to find y triple dash. Considering y double dash, I am going to find y triple dash. Consider y double dash, which is equal to 1 by x plus y dash divided by y. Now differentiating partially with respect to x. Now y double dash becomes y triple dash, which is equal to differentiation of 1 by x. It is very easy. Differentiation of 1 by x, you can represent it as x to the power of minus 1. What is differentiation of x to the power of n? N into x to the power of n minus 1. In place of n, we have minus 1. Just replace minus 1 x to the power of minus 1 minus 1. Minus 1 into x to the power of minus 2. Minus 1 whole divided by x square. Differentiation of 1 by x is minus 1 by x square plus, now since it is in the u by v rule formula, okay, I am going to represent u by v rule formula here. What is u by v rule? U by v rule represent v u dash minus u v dash divided by v square. Got the point? Here I am going to simplify. U represent y dash and v represent y. Got the point? Yes. Let us erase all this part. Just simplify, go on simplification. Just okay. After this, okay, use the brackets, minus 1 by x square plus. Now I need to simplify by u by v rule, that is quotient rule. Now what is v? V is y. Now u dash, what is u? U is y dash. When it becomes u dash, y double dash, minus, next u, what is u? Y dash. Next we have v dash. V is y, v dash means it becomes y dash, whole divided by v square. What is v square? Y square. That's it. Got the point? Now y triple dash, which is equal to minus 1 by x square. Just split numerator denominator. Since, see, if you they have asked only for third degree term, it was not necessary to split. If they ask for fourth degree term, for simplification it will be easy, so I am going to split the part. So what I am going to do, plus y into y double dash by y square, minus, plus into minus, minus y dash whole square divided by y square. See, y get cancelled, y triple dash, which is equal to minus 1 by x square, plus y double dash divided by y, minus y dash the whole square divided by y square. This we call it as third degree derivative of y triple dash. See, we found y triple dash of x also. Now what we are going to do? Now we are going to simplify the values. How to simplify the values? Y triple dash of x naught, okay, minus 1 by, what is x square? X square is 1 square, minus 1 by 1 square, plus what is y double dash value? Y double dash value is 1.3465 divided by y. What is y? 2, minus y dash the whole square. What is y dash? Y dash is, see, that is 0.6931 whole square divided by y square. What is y square? That is 2 square. Use the calculator, you get the value of y triple dash of x naught. Okay, let us use the calculator and represent the solution. Done. Now represent however it is, minus 1 divided by 1 square, plus again numerator denominator 1.3465 divided by 2, minus numerator denominator 0.6931 into whole square divided by 2 square. You get minus 0.4468. This is the value of y triple dash of x naught. This is the value of y triple dash of x naught. After finding y triple dash of x naught, the last term is, which is I am supposed to find, is y fourth degree of x naught. Now what I am going to consider? You always know which I am supposed to consider. You can predict. I need to consider this one, that is y triple dash. That is, I am going to consider y triple dash, that is y triple dash, which is equal to minus 1 by x square plus y double dash divided by y, minus y dash whole square divided by y square. Got the point? Now again, applying u by v rule only, we are going to simplify the condition. For this, let us simplify, differentiate partially with respect to x. The last differentiation, it becomes fourth degree, that is y to the power of 4, which is equal to, again minus will be constant, differentiation of 1 by x square, you can represent it as x to the power of minus 2. Neglect minus sign. See, x to the power of n, you can differentiate as n into x to the power of n minus 1. Now n is minus 2. minus 2 into x to the power of minus 2 minus 1, minus 2 into x to the power of minus 3. X to the power of minus 3 you can write it as 1 by x cube. Now see, see what happens, minus of minus 2 by x cube. The differentiation of 1 by x square is minus 2 by x cube. That is minus of minus 2 by x cube plus, now u by v rule formula. Again represent u by v rule formula. Okay, now what will be u? U will be y double dash. U will be y double dash and v will be y. Simplify as it is in the condition. Okay, use the brackets. What is v? V is y. Okay, what is u? U dash. U is y double dash. If it becomes u dash, it becomes y triple dash. 1, 2, 3. Minus, what is u? U is y double dash. Now, what is v? V is y, but I need v dash, so it becomes y dash. Whole divided by v square, that is, what is v square? That is y square. Minus into, now again see, I have v as, sorry, u as y dash whole square and v as y square. Now let us simplify and represent the terms. Minus of, now v, what is v? Y square. Next u dash means, see, u is y dash the whole square. Okay, u dash means I need to differentiate whole term, so 2y dash, got the point, into I need to differentiate inner term. What is differentiation of y dash? It becomes y double dash. This is the value for y double dash. Got the point? First you need to differentiate whole term, then you need to differentiate inner term. That is, what did you get? That is 2 into y dash into y double dash. Close the bracket. Got the point? Minus, next the minus u. What is u? Y dash the whole square. Next v dash. What is v dash? See, I need to differentiate v square. Okay, I'm going to simplify here. Look, v equal to y square, but I need to differentiate this because I need v dash. So what I'm going to do, it is very easy. V dash means first differentiate whole term. Differentiation of y square is 2y. Got the point? Now differentiation of y is dy by dx. You can represent it as 2y into y dash. 2y into y dash, that is 2y into y dash whole divided by v square. What is v? V is y square. V square becomes y to the power of 4. Y to the power of 4. Got the point? Now let us simplify. Y to the power of 4, which is equal to minus into minus plus 2 by x cube plus, you can split the terms, y into y triple dash by y square minus y dash into y double dash divided by y square minus, plus into minus, 2 y square, just I am rearranging, y dash y double dash whole divided by y to the power of 4. Next minus into minus plus, you have 2 y dash whole square, y dash, you get y dash whole cube divided by y to the power of 4. Got the point? Now let us see which are the terms get cancelled. Y, here it is not possible, y square and y power 4, y and y cube. Y power 4th degree 2 by x cube plus y triple dash by y minus y dash y double dash by 2, not 2, y square, sorry, y square minus 2 y dash y double dash divided by y square plus 2 y dash the whole cube divided by y cube. It is very easy. Just practice 2 times, you get the conditions. Twice y to the power of 4. Now let us represent the terms and simplify the condition. Got the point? Yes. Now let us simplify the terms. Which are the required terms? 2 divided by, what is x? X cube. X cube represent 1 cube plus y triple dash. What is y triple dash value? We have minus 0.4468 whole divided by y. What is y? Y is the value of 2 minus y dash. What is y dash? Y dash is 0.6931 into y double dash. What is y double dash? Into 1.3465 divided by y square. What is y square? That is 2 square. Next, minus 2 into y dash. Again 2 into y dash. Okay, you can add this also. See, minus you can add this to. Okay, represent, nothing happens. That is y dash 2 into y dash 0.6931 into y double dash. What is y double dash? We have 1.3465 whole divided by, again y square. What is y square? That is 2 square. The last term I don't have space, I'm going to write below. 2 into y dash the whole cube. What is y dash? Y dash is 0.6931 whole divided by y cube, that is 2 cube. Use the calculator. Let us represent y to the power of 4. Done. Now take the calculator. Let us simplify the condition. Okay. Now let us simplify in the calculator. 2 divided by 1 cube. It is also necessary. It is not necessary. 1 cube is 1 plus, again numerator denominator, minus 0.4468 divided by 2. Next, minus into, again press numerator denominator, minus into 0.6931. Please be careful while giving the values. 0.6931 into 1.3465 close the bracket divided by 2 square. Next, minus, again numerator denominator, 2 into 0.6931 close the bracket into 1.3465 close the bracket divided by 2 square. Okay, if you get this one, press equals plus the last term we have, again numerator denominator, 2 into 0.6931 whole cube divided by 2 cube. Get 1.1598. You get 1.1598. That is by 4th degree of x naught. Okay, x naught, which is equal to 1.1598. Got the point? Yes. After representing this, now after finding all the 4th degree term, now let us simplify in Taylor series expansion. Okay, by using Taylor series method. Okay, by using Taylor series method, we have y of x. that is y of x, which is equal to, what is y of x naught? X naught is 1 plus x minus x naught, that is x minus x naught. What is x minus x naught? 1. Okay, y dash of x naught. What is y dash of x naught? That is 0.6931 plus, next we have x minus 1 x naught, that is whole square 2 factorial is 2, and y double dash of x naught we have 1.3465 plus, next we have x minus 1 whole cube divided by 3 factorial, 3 into 2 into 1, 3 2s are 6, into y triple dash of x naught. What is y triple dash of x naught? Minus 0.4468 plus the last, that is x minus x naught is 1 to the power of 4, 4 factorial, 4 into 3 into 2 into 1, 4 into 3 into 2 into 1, 4 3s are 12, 12 2s are 24, 24 into 1, 24, 24 into y fourth degree of x naught, you get 1.1598. Got the point? Now, this is, we call it as the Taylor series expansion of the given differential equation. Is the, okay, we can represent the tabular column also. Is the required Taylor series expansion for the given differential equation. Is the given differential equation. Now we have found the Taylor series expansion. Considering this, we are supposed to find the value of y of 1.1 and y of 1.2. How? Let us see. Okay, since I don't have space, I am going to erase this part. I hope you have copied on. Okay, let us simplify. Now we need to find y of 1.1, where y of 1.1, which is equal to, what is y of 1? Y of 1 is, see, y of 1 is 2 plus x. What is x? 1.1 minus 1 into 0.6931 plus 1.1 minus 1 whole square divided by 2 into 1.3465 plus 1.1 minus 1 whole cube divided by 6 into minus 0.4468 plus 1.1 minus 1 whole to the power of 4 divided by 24 into 1.1598. What's the point? Y of 1.1. Use the calculator. It is very easy. Okay, you simplify by using the calculator. 2. While simplifying, please be careful. 1.1 minus 1. Okay, cross verify twice into 0.6931 into 0.6931 plus, again numerator denominator open bracket, 1.1 minus 1 whole square divided by 2 into 1.3465 close the bracket plus, again numerator denominator, 1.1 minus 1 whole to the power of 3 divided by 6 into minus 0.4468 4468 plus numerator denominator again 1.1 minus 1 whole to the power of, okay, since it is not taking values, just let us represent press equals plus 1.1 minus 1 whole to the power of 4, okay, whole divided by 24 into 1.1598, close the bracket. We get the value 2 point, okay, after simplification you are going to get 2.0759, that is 2.075123.9, okay, up to 4 decimal places of the Taylor series method. This is the value of y of 1.1. Similarly, let us solve y of 1.2. y of 1.2, 2 plus 1.2 minus 1, 0.6931 plus 1.2 minus 1 whole square divided by 2, 1.3465 plus 1.2 minus 1 whole cube divided by 6 minus 0.4468 plus 1.2 minus 1 whole to the power of 4 by 24 into 1.598. Okay, please don't be in a hurry, so that you are not supposed to do the mistake. If you do some silly mistake, the solution will also be wrong. But the point, don't do the mistakes. Okay, 2 plus 1.2 minus 1 into 0.6931, close the bracket, plus numerator denominator 1.2 minus 1 whole square divided by 2 into 1.3465 plus again numerator denominator 1.2 minus 1 whole cube divided by 6 into minus 0.4468 plus, okay, press equals plus numerator denominator 1.2 minus 1 whole to the power of 4, that is 1.2 minus 1 whole to the power of 4 divided by 24 into 1.1598, close the bracket. You get 2.1650. You get 2.1650. This is the value of y of 1.2, which was the required solution to simplify the Taylor series expansion. Got the point? Now let us take a recap so that it will be easy to analyze. First, see, represent the given Taylor series expansion. After representing Taylor series expansion, represent the given terms. After representing the given terms, find y dash of x naught. You got the value y dash of x naught as 0.6931. Considering first condition, represent y double dash. You get the derivative function, derivative equation 1 by x plus y dash by y. Simplify the values, you get y double dash of x naught. Consider y double dash, represent y triple dash. See, considering this, applying u by v rule, quotient rule, we have represented y triple dash. Split the terms, it will be easy to analyze. Substitute the values, you get y triple dash of x naught. Considering y triple dash of x, differentiate with respect to x, you get fourth degree. Split the term so that it will be easy to differentiate. Use this term, it will be easy to simplify in the VTU main examination. Nothing more, I have explained step by step. Just differentiate, just simplify. Either you can see, either, since these two terms are same, you can add. See how you can add minus 1 minus 2, you get minus 3 by y, minus 3 into y dash y double dash by y square. Got the point? If you simplify, you get y fourth degree of x naught. Now, considering all these terms representing Taylor series expansion, if you simplify in Taylor series expansion, this will be the required expansion of the given differential equation. Now, in place of x, if you substitute the value whichever they have asked to find, y of 1.1 and y of 1.2. The value of y of 1.1 will be 2.0759 and y of 1.2 will be equal to 2.1650. This is how you are supposed to represent a Taylor series expansion in the VTU main examination. I hope you have understood each and every step of Taylor series expansion. If you have liked this video, please do subscribe, share. See you in the next video. Thank you.